in AS3008, 3008, there's the 35% rule. For example, if you have a cable which installed by itself in normal conditions.
So you don't apply the 0.38 rule?
Flat lid, peak lid, that will make a bit of a difference, obviously.
Trying to wrap your head around the old AS3008 35% rule. Here's a small snippet from a larger conversation I had with Gil Rhodes, RPEQ, where he goes into detail explaining what that 35% rule means. You know, there are these grey areas inside the standards. And I'll give you an example. Bunched on a surface,
yep.
DC cable in cable tray on the roof, right? Mm-hmm. After 20 circuits, the derating finishes. At 20, it's 0.38.
Yep.
And after that, it's like, it ain't even there.
Yeah.
So my question is, if I put in 21, 22, 23 circuits, do I still apply the 0.38 or do I apply something that is not there?
Okay, two parts to this.
I love it.
And the two parts that depend on the ratings versus the current going through each cable. So if you have, say, a cable which is loaded, then that is obviously going to, we talked about operating temperatures.
Yes.
It's going to heat up. It's going to be a contributing factor to heat surrounding heat with surrounding cables and that sort of stuff. That's where we need to take that into consideration. However, in AS3008, 3008, there's the 35% rule. So and you can find that in there in a couple of different places.
Okay.
So, for example, if you have a cable which installed by itself in normal conditions,
yep,
is rated for, say, what's a standard string cable rated for? About,
let's say 6 mil, it might be 67 amps, something
67
like that.
amps.
I think so,
right.
yeah.
So how much current do you actually put down that cable?
With some of the bigger panels, let's say that you do push the ISC on some of the bigger panels, maybe 14 amps.
14 amps.
Unparalleled.
Unparalleled. Okay, so if we're talking about 14 amps with a cable rating of approximately 67, so let's just say 15 amps and 60 just for round numbers here. So that is actually 25% loaded. So that technically is less than the 35% rule.
Yep.
Therefore, you don't actually have to worry about deratings.
Hang on a sec.
Hang on a
sec. You say you don't apply the 0.38 rule?
To a degree. Obviously, it has to be assessed, has to be looked at. I'm not saying it's a blanket rule that just applies everywhere. It has to obviously go through an assessment process. But for example, if we're talking about, say, in a building, we've got lighting circuits going up through, sitting on some tray or whatever else that's there, and they're all together, and those lighting circuits are rated for 16 amps. And we're putting in some LEDs, might be a couple of amps each. Then you don't have to worry about them with any sort of contributing heat to the other circuits. So 35% rule kicks in. We don't actually have to worry about applying any deratings to them.
But if you're talking about DC cable bunched in a tray, and I'm talking about if it's not cable tied nice and neatly, and then there's a question there I'm going to ask, that if you open up the tray, the cable spills out like the entrails on a samurai movie, right? You know what I mean? And the reason I say this is this, because I was trying to establish during the training that the best approach financially and that intrinsic relationship between am I running single strings unparalleled and their relationship to how many other strings are in that same cable tray, which relates to the size of the cable tray, it's said, and all those relationships, because it's very important.
That's right.
And I basically came up with, and I'll jump in here, what we tend to do on our commercial jobs, we don't parallel any strings at all, and we use string fusing at the inverter, so we can get away with the, say, 110 kVA sun-grown, not using a 25 mil earth
for all the arrays
unless
and
there's
stuff.
And this is roof mount, unless there's some lightning protection, which changes everything anyway from an earthing perspective, because 25 mil earth is very expensive on a 1 megawatt system, and then of course there's other aspects about if you parallel, you need Y connectors and all that labour. It's trying to work out that nitty gritty,
that optimum
that optimum point.
Yes.
So I assume straight away that if you're putting like slightly over 20 circuits, 20 runs of pos and neg, 6 mil, which is 67 amps, and you're going over 20 times 0.38, you're well okay.
Yeah.
But the question is, if I put 25 in, what happens then? Is this where that 35% rule kicks in?
Well, you'd probably be looking at the 35% rule first. So you'd be having a look at that and going, okay, how much do I need to apply to this? But then if I look at if I look at the 20 and I realise that, you know, having 20 circuits around, I mean, physically, one cable with another 19 around, it's obviously going to be fairly tricky to facilitate.
In a 150 mil tray.
And, you know, you are sort of looking at that going, okay, let's have a look at, you know, it being practical. And can you actually space these out a little bit? You know, as you said before, we're not talking about like, you know, entrails with samurai movies and all that sort of stuff. Yeah. But we're talking about.
Well, you can stack them, but then again you're restricted by the height of the height of the cable tray.
That's right, and all you're trying to do is just trying to maximise as much airflow as possible.
Correct.
So, you know, flat lid, peak lid, that will make a bit of a difference, obviously.
We've had this conversation before.
We have. I know, a few times.
Yeah.
So I guess it comes down to just doing the assessment on it. And look, at the end of the day, if you're ever unsure, then use a job that you're doing during your testing and commissioning to go and actually do some other testing on there. Like let the system run for a few hours during the middle of the day, lift a section, get a thermal camera and have a look. And so this is, you know, something that we're doing with, you know, some of the works especially, that, you know, connections and switchboards and stuff like that, is that if you are unsure, you know, and if the switchboard builder might be a little bit iffy about things, go, okay, how about we actually do a before and after thermal camera assessment?
Yep.
That it might just come down to a little bit of extra testing that we need to do in testing phase that will satisfy our sort of questions.